In this tutorial, I'm going to show you how to use Python for scientific calculations. In this tutorial, you're going to learn how to use the math functions inside of Python and where to find them. I will also show you some basic math functions like how to integrate a function. First of all, we're going to define the function, then we're going to integrate it. I will also show you how to find the roots of a polynomial. And lastly, I'm going to show you how to plot 2D graphs inside of Python using NumPy and Matplotlib. I hope you'll find this tutorial very helpful. In this tutorial, I'm going to show you how you can use Python to do basic scientific calculations. So the first thing that I'm going to introduce you to is the math module. So the math module inside of Python is a built-in, and it contains most of math functions. So let's just go to the help to find out which functions are available. So in order to do that, we type in help. If we run the code, it gives us all the available functions inside our math module. You can clearly see we have arc, cos, arctan, we have cos, degrees, f. You can go ahead and read all the documentation to see all the possible functions inside, but I'm just going to go through some of the few basic ones. So in order to use the math module, we simply need to import it. Import math. But very important to note, the math module always takes in arguments in radians. For example, if I type in sine 180, first of all I need to say math dot sine. If I do this, and then let's run the code, save it, it gives us this, but we both know the correct answer is actually 0. So it does that because it takes in arguments in radians. So we can solve the problem by simply typing math. Oh, we also have another function available called pi. So math.pi gives us the pi value. So let's go ahead and run it. Math.pi. Okay, let's do it this way. From math import pi. Okay, so I see what the problem was. I shouldn't include these brackets. Okay. So let's go ahead and do our example. Math sine 180, and it gives us this. So in order to change this 180 and make it into radians, we can use the same math function. I'm gonna type in the name of the module dot radians. So whatever argument value we pass inside this function, it's gonna be converted into radians. For example, I'm gonna type in 180. It's gonna convert that 180 into radians. So let's go ahead and run the code. We can clearly see that it gives us a 0. This is 1.224 to the power of 10 to the negative 16. So another thing to note is that whenever you see the small case e followed by a number, it usually indicates that this is an exponent. It does not mean e for the log, it simply means it's exponent. This is 10 to the power of negative 16. Okay, now I'm going to show you how you can integrate inside of Python. We're going to use the SciPy module. So I'm going to say from SciPy module import integrate. Then I want to print whatever I'm going to integrate. Dot quad. I'm going to look for this function called quad. This is the one we're going to use to integrate. You can see it takes in 3 arguments. The first argument is the function you want to integrate, and then the last 2 arguments is the range of values where you want to integrate it to. So let's pick an easy example. So I'm firstly going to import the sine from math, import sine, and maybe pi and cos. Okay, so the function we're going to integrate is cos, and we're going to integrate it from 0 to pi. Okay, you can check this answer with your calculator. So let's go ahead and run the code. If we run the code, this first answer here gives us the correct answer. Okay, so this is our correct answer. Let me just clear everything up here so you can see it clearly. The first argument here is the correct answer. So that's how we do integration in Python. We use this module called SciPy, stands for Scientific Python. You can use this math module. But say for example we have a different function, we have x squared or a polynomial. The way in which we can do that, we need to define our function first. I'm just going to call it fn. Takes in one argument x, and okay, let me just say function so you can understand. And then this is my function, it's just x. My function is just x. So I wanted to return function. Okay, now we've defined a function, it's a polynomial. So in line 19, I'm simply integrating this function as I've defined it here as fun, and the range of values in which I want to integrate this function is between 1 and 2, as you can see with my last argument. You can check this on your calculator to see if it does the correct calculation. So line 13 to 16, it's another block of code. I'm simply defining a new function. So let's go ahead and run it and see what will be the outcome. It gives us 1.5, and if we do it at the calculator, we'll see it gives us the same answer. We can also make this squared, for example. Let's run it and it'll give you the correct answer. So that's how we use Python to do integration. Another helpful functions is finding the roots of a polynomial. The way in which we do that, we need to use the NumPy module. So we need to import NumPy, and we're gonna we want to print out NumPy dot poly. Let's try that again. Okay, then we go ahead and we need to put in polynomial again. Then on polynomial we need to go to polyroots. We come here. It's very important that you include both polynomial. So inside this module NumPy, you're gonna find another function called polynomial, and inside this polynomial you'll find another function called polynomial, and inside of the polynomial function you're gonna find another function called polyroot. And after polyroots you click shift open bracket, and then now you need to include your polynomial coefficients. Remember, the first argument will be the lowest power, or the lowest power of your polynomial. Say for example it is x plus 1. So if I put in 1 and I put in another one, this is 1, this is the coefficient 1, this is just an integer, and this one is the coefficient of x. So my polynomial is actually x plus 1 equals 0, and I want to find the root of that. So if I run the code, it should give me -1. Okay. And I can also make this maybe 4, and then make this 0, make this 1. Let's try to run it. You can see it gives us complex numbers. Let's rather do this -4, and we know the correct answer is -2 and 2. So my polynomial as it stands here, it has x squared, and then it has -4 equals to 0, and we all know that should give us two roots, -2 and 2. So this is how we use Python to determine the roots of a polynomial. Remember, the first argument you put inside will be the lowest power. So this one is just an integer, this one is x, so I used 0, so it means that the x value doesn't exist, and this one is 1, it's the third argument, which means that the highest power that is available is to the power of 2. So this is x squared, 1x squared. If I put in 8, it means that this is 8x squared. So that's how we find the roots inside of Python. Now I'm going to show you how to plot graphs inside of Python. We're going to be plotting 2D graphs. When plotting in Python, we usually use two modules, one for storing the data and the other for the actual plotting. We use NumPy for our data containers. With NumPy, we can define an array of values. Arrays are similar to lists, but they have more flexibility. Then we use matplotlib to plot our graph. Let's have a look at an example. So we said that we use two modules. Let's start with the first one, NumPy, and then the second one is matplotlib. Okay, so the first thing is that we need to define an array. So to make things easy, I'm going to plot the function sine. I'm going to plot the sine function. And in order for me to plot the sine function, I first need to have the time values or the x variable for my graph. And I can simply create that by creating a NumPy array. So I'm going to define a new variable and I'm going to call it xvals to indicate this x variables. Then I'm going to say NumPy dot array so I can define an array like this: 0, 0.1, 0.2. But say for example I want values between 0 and 2 pi. Now we all know that there's infinitely long values between 0 and 2 pi that I'd like to plot, and if I use finite values I'm not gonna get a very perfect graph. So in order for me to do that, to overcome that challenge, I can use a function inside of NumPy called linspace. Okay, so pi so the way in which linspace works is that it will plot my graph for values between 0 and 2 pi. Let me just include the 2 pi there. And the values that are going to be inside could be 1,000. I can even make it 1,000,000, or how many number of times that I want to. So this saves me from having to create all the x values and type them using a list or whatever method that is possible. This is one of the easiest way to create a list or an array of values. So if printed, say for example I want 10 values, from math import sine pi. Let's just do pi. Let's just print our xvals. You will see that it has 10 values. It prints an array. This is not a list, it's an array, and it has 10 values equally separated equally apart. And I can also make it 100. And it will give me 100 values between 0 and 2 pi inclusive. By inclusive I simply mean that it will include 2 pi and it will also include the first value 0. So now that we created our x values, now we want to create our function, and to do that we're simply going to use yvals. So this will be on our y axis, NumPy dot sine. And the reason why we're using NumPy dot sine instead of math is because if we use this, it will not give us an array. Now just to show you what I did in line 15, I'm going to print my yvals. It's also an array, Let me just erase this so you can clearly see. If I run the code again, you can clearly see the value for sine 0 is 0. It's correct. And the value for sine 2 pi is also 0. It's just represented as an infinitely small number inside of Python. But you can clearly see -2 to the power of -16. It's close to 0. So this is 0. So this is what it does in line 15. It simply creates the function value of the x values. So now that we have our y values corresponding to our x values, so each x value here corresponds to this y value. Now we need to plot it. We're going to use the matplotlib module, but not whole matplotlib module. We only need a specific function inside that, and it's called pyplot. Import pyplot. Okay, pyplot. Okay, pyplot plot. Okay, before I continue with this, it's very important for you to use help from matplotlib import pyplot help pyplot dot plot. Okay, if you search for the help regarding this function, it'll pretty much tell you everything you need to know to use it. But basically it takes in two arguments. Let's rather say pyplot it'll give you all the functions that are available inside of pyplot. Let me try this. Okay, this is very much better. Okay, so if you were to type this in, it will see it takes in usually 3 values. The first one is your list of, or an array of x values, and then the second one is your y values corresponding to the x values. So in my case, if my x values do not correspond to my y values, then it won't be able to give me a correct plot. And then the third argument, which is sometimes not necessary, is to define how you want it to be. Do you want a line? Do you want it to be dotted? And you can check this all out from the help documentation here. You can see here, if we pass this for third argument a dash line, it will give us a solid line. If we pass in to dash, it will give us a dash line. If we put in a dash and a dot, it will give us a dash dot line style. And if we put in a colon, it's going to give us a dotted line. And this one will give us point markers. And we can also even change the color of the line. So let's go ahead. So the first argument we want to pass is our xvals. That is the variable here. Then the second argument we want to pass is our var values. Then the last argument that we want to pass is our line. How do we want our line to be like? We want it to be a solid line, as you can see here on our help documentation. If we put in a dash, a simple dash, it will be a solid line. And say for example we want it to be red, I'm gonna choose R. Scroll down, red stands for R, G stands for green. So if I put in G, it's gonna be a green line. If I put in B, it's gonna be a blue line. If I put in K, it's gonna be a black line. So let's leave it there with red. So in line 19, what I'm simply doing is creating a new canvas. Before Python can plot, I need to create a canvas where this plotting will take place. If I just leave this blank, it will not plot. It will plot, but it will not show me anything. So it's important for you to use this function called pyplot.figure. So here you can have many figures. You can have 5 different graphs, and you can all number them by putting an argument inside this function called figure. In my case, it will be the first figure, so I named it 1. So in this figure, I am plotting this. And then when I'm done, I'm simply gonna say pyplot dot show. It's very important that you include line 23 and line 19. Pyplot.figure creates the canvas. 23 simply shows the canvas. So let's go ahead and run the code and see if it will do what we expect it to do. If we run the code, we see it gives us the sine wave, but it looks kinda distorted, and the reason why is because we don't have enough points. So if we go ahead, if you look at line 12 here, we see we only have 10 points. So it's only plotting for 10 points. 1, 2, 3. We can even count them. It's only 10 points that are equally spaced. Another thing that we see is that our graph doesn't have any titles, doesn't have an X label. So we can solve that using the pyplot function. So let's go ahead and do that. First of all, we want 1000 values here that are equally spaced. So this will give us 1000 equally spaced X values. And because our function here, the Y values, simply uses the X values, it will give us the corresponding Y values. We're gonna come here. Now we're gonna add some more functions. pyplot.x label. I'm simply gonna have X values and pyplot.y label. And let's also put in a title, pyplot.title. Okay, let's try to run it again. Okay, let's just first close this first. If we run it, we see now we have our y label and we also have our x values, but not only that, we also have a title for our graph. So in short, this is how we do plotting inside of Python. We're using two modules, the NumPy module to store the data. We're creating the x values, then our y values. We can even plot y values could be equals to x vals squared. Now we're plotting the function x squared. This is the actual function that we're plotting, x squared. X squared. So let's go ahead and see what that will look like. We all know this is a function of an exponential or of x squared. Of course, now this is not correct. This is supposed to be x squared. So this is how we do plotting inside of Python, and this is how we do scientific calculations out of Python. For more information, you can simply type in this function and find out more help and play around with it. Thank you for watching.